Today I'm going to be presenting to you on the topics of AppArmor and HTTPS, along with two other services that are used, such as Microsoft's IIS and Apache Web Servers. So with that said, let's get started. You can say hi to my helper in the back. She looks like she fell asleep. Thanks, Chloe. Alright. So first off, what is AppArmor? AppArmor is a MAC system, which is a mandatory access control system, and it is a kernel enhancement to confine programs to a set and limited set of resources. So it acts to basically compartmentalize or as a container to programs rather than users, and it will limit the resources that they can access. It's also path-based, such as a lot of things in Linux. AppArmor has two separate modes, enforcement and confined mode. In enforcement mode, it's going to enforce the containers, so it's going to force policy compliance, and you won't be able to access other stuff that you don't have the rights to. In compliant and learning mode, it's just going to report it, and that would be useful in, say, like an environment where you're trying to test and make sure that the rights are set correctly. And you're allowed to mix these two modes. So next up, we got some basic commands for AppArmor. You got the sudo AA status, which is going to be able to check all the profiles along with details and the status of those profiles that you put in. And then we also have an enforce and compliant mode, which you can use with sudo AA enforce, and either enforce or compliant, and then the path to bin. So some advice for AppArmor hardening. First thing you're going to want to do is the sudo apt get install AppArmor profiles, and this command is going to get and install commonly used AppArmor profiles such as for Firefox and so forth. There's the sudo apt install y AppArmor utilities. This is just going to add various utilities you're going to be able to use. It's going to help ease access. The AppArmor notify package, you can look more into this just by looking it up, but it's going to create desktop alerts to policy violations, and you could reroute these to probably give you like email notifications and stuff like that, because I mean, let's face it, you can't be sitting in front of the desktop 24/7. And most importantly for hardening, you got to enable logging. Logging is one of the only ways you're going to be able to possibly dig into problems and figure out what's going on if there is an issue, along with proving policy violations. So next up, we got HTTPS. HTTPS is the same as HTTP, but it adds the features of encryption, authentication, and integrity. So we got this next slide here. It's just kind of explaining the handshake that happens. You got the TCP handshake right here, and then it's going to do the send act that's going to establish the connection, and then you have the transport layer security, which is what makes HTTP so special. You're going to get the client hello, the server hello certificate, and server hello done, which actually, if you look at the next slide, this is three separate things getting sent back from the server. And then the client is going to essentially send the same things back, along with the change cipher spec, and then it's going to send the same thing back from the server, and then give a finish. And you can see that a little more broken down in this slide. I just put two in here because it might be easier to visualize each step separately. So next we got this is just a little slide kind of comparing what is HTTP versus HTTPS. HTTP, it's going to work on port 80. HTTPS is going to work on port 443. It's encrypted. It works with the transport layer. HTTP works with the application layer, and it uses clear text transmission. This could be a problem because, say, if here, got one. Hey guys, sorry about that. It looks like it wasn't recording, so real quick I was just trying to do a live kind of demonstration. Say if we went to PayPal, say we went to PayPal's login, and we got our field here where you log in. So say I was trying to rewrite this or something like it, since it's in HTTP, I could theoretically reroute all the traffic to go through from the server through my computer to your computer if there's no endpoint security. So that's the perk of HTTPS. It adds the point-to-point security, and you don't have to worry about stuff like this where, say, I'm in the middle of your session and I am currently modifying packets as they go by. Like I'm grabbing, say, this HTTP as it goes by over here, and instead say get your enter mobile number over here. If I were to just let's just change a placeholder here for a proof of concept. You got hacked. And now it says that. Now I know that's just a placeholder right there, but you can also change down here what it's sending it off to. You can change any of this if you are able to modify the HTTP before it gets to the other person's computer, and then it would just send it over to the computer. They'd see this form here, not with how you get hacked, but maybe it would just look like a normal form. They log in through their stuff. It would send it through your computer. You'd capture all the traffic there, and then send it off to PayPal. They don't have an idea that anything's happened there. Perks of having the transport layer security in place. So here we'll cut back over to the presentation real quick. Alright, so then just a real quick cover. We're going to talk about web servers also real quick, because they use HTTP, HTTPS, and they're basically going to run their own various scripting languages on the back end, and they turn any information that someone is requesting from the server, clients requesting from the server, into static HTML files that can then be served to the users. The HTTPS, again, comes from adding the layer of transport layer security. So the web server is just changing it to HTML files and then submitting them over to the clients, along with running any other scripts that happen on the back end. The first one we'll talk about here is the IIS and Windows server, the Intranet Information Services, and it supports all these functions here: HTTP, to S, FTP, so forth. All these. And it basically, installing this feature on any Windows server is going to remove unnecessary components from the server, such as you won't need like domain accesses and stuff like that. It's gonna help kind of lock it down the same sense that AppArmor sort of does with Linux. Not in the complete same sense, but it's gonna help remove not AppArmor. It's gonna help remove a bunch of the services that don't need to be running. So some IIS hardening techniques for the Windows one. You should run it in a separate container from the rest of the environment. The idea of compartmentalization. You shouldn't have it running on the same things as, say, like domain controllers and stuff, and that stands for a lot of the different components in these environments. Disable any features not in use, which luckily it does that for a lot of the IIS features, but I mean there are a bunch of other features on a Windows device that you'd probably want to disable. And use the firewall to ensure that you're only receiving valid packets. You don't want, if you aren't checking these packets, you won't be able to distinguish between when you're getting like a DOS attack or someone's trying to take down your servers by just flooding packets with invalid information. And then you're going to want to turn on SSL and maintain SSL certificates. This is going to be essentially what establishes it as being HTTP versus HTTPS. Adding the secure socket layer, which also known as transport security, or was it transport layer security? They kind of used interchangeably. I believe the newest term is transport layer security. But make sure you keep up with those certificates, because as soon as you don't, they will no longer use HTTPS, can't validate it, and I've worked with city government sites that they forget to keep up with the certificates a lot. I don't know if it's still the case. You might be able to go look at the Department of Driver Services, and last time I checked them, they didn't even have any certificates. Alright, Apache and Linux. So Apache is an open source web server. It uses quite a few different flavors and variants. So like you have NGINX, which runs pretty much the same, and then you have Tomcat for running Java on the back end. They have a couple different flavors there. You can go out and research them as you need them for your various tasks. They're supposedly really easy to use. They come as a Apache web server, I'm sure you heard this before, but it's a bunch of different components just put together, and it makes a web server basically. There is issues though with the Apache web server since they use threading. If there's high traffic, you can see some issues from that. Some hardening techniques. Make sure you hide the Apache version in OS from errors. You can disable this by going through some various files and telling it to not respond with, say, when you send out a ping or a invalid packet that it doesn't send back, that the server doesn't send back a reply saying, oh, this request cannot be complete, here's the current Apache version, here's the current information about the server. Also, you should make sure you keep it up to date. That just goes standard for any software on these things. You should also run Apache as a separate user and group. And be sure to use the mod security and mod evase modules to secure it. The mod security is a firewall for web servers that lets you monitor traffic in real time. And then the mod evase is going to prevent DDoS attacks. They're just two really useful modules you should probably look to install on your servers. Got a few different sources here. And that's it. So I appreciate you all taking the time to watch this.